If you have ever been on a road trip, you would know the real headache isn't packing or arranging a vehicle. Rather, it is figuring out the best route so that you don't waste time going back and forth between places. Say you are planning a trip across India to cover Spiti Valley, Pangi Valley, Ladakh, and Kashmir. How do you decide which order to visit them so that your fuel cost stays low? Most of us rely on Google Maps, checking each location one by one, comparing distances, and then manually arranging them to make sense. For me, this manual planning process is by far the most frustrating and boring part of a road trip. This motivated me to automate the route planning process. As I started researching, I realized I would need two main tools. First, a digital map to calculate the shortest distance between any two locations, and second, an optimization solver for solving the traveling salesman problem. For those who are not familiar, the traveling salesman problem in operation research identifies an efficient route for visiting multiple places. This is exactly what we need for an automated route planner. However, the catch is that solving the traveling salesman problem is NP hard. In simple words, as the number of places increases, time to compute the optimal solution increases exponentially. That's why, for a large number of places, we would have to settle for near optimal solutions. Mind you, for most practical cases, this suboptimal solution would still beat a manually planned route. With that in mind, I started looking for existing solvers that could handle the traveling salesman problem. And that's when I came across Google's OR-Tools, an efficient solver for standard discrete optimization problems. To tackle the traveling salesman problem, OR-Tools requires a two-dimensional matrix that stores the distance between every pair of locations. For instance, if I plan to visit Srinagar, Leh, Manali, the matrix would list the shortest path from each city to every other one. So, the next challenge was to generate this distance matrix automatically, which required a search for a digital map. At this point, I had two choices, Google Maps or OpenStreetMap. I went with OpenStreetMap because it's fully open source, and unlike Google Maps, there are multiple free API providers. This way I could keep the project cost close to zero while still having a reliable map data. Now that the theory is clear, let's break down the system into smaller components. Step 1. The user types in their desired locations in a search box. For each new entry, the system fetches its GPS coordinates using geocoding servers. Step 2. Once all places of interest are specified, the user clicks the button to compute the optimal route. This triggers API call to calculate the shortest distance between every pair of locations. To do this efficiently, we should use Matrix API instead of the routing API. This is because Matrix API returns the entire distance matrix in a single API call. This saves both time and reduces the number of API requests. Step 3. We pass the distance matrix to OR-Tools for solving the traveling salesman problem. The output solution is the sequence in which one should visit the places of interest. Step 4. With the optimized location sequence, the next step is to visualize it. For this, the sequence of places is sent to the routing API to fetch the actual route on a map. I made a working prototype by integrating the individual parts using JavaScript, PHP, and Python. I'll be the first to admit that the UI still needs work. But since the code is open sourced, I'm hoping someone can help improve that part. For now, let's just see if the system works as expected. Using the location search box, I will add a few of my favorite places so far. Starting with Srinagar, Leh, Manali, Killar, Rekongpio, Chitkul, Sonmarg, Padum, McLeodganj, and Tapo. Having added all the places of interest, let's compute the optimal travel route. This step takes a few seconds as the backend service builds the distance matrix and passes it to the OR-Tools solver to solve the traveling salesman problem. And here's the result. You can see the map with all the destinations and highlighted paths showing the optimal route. If you scroll down, you will also see the optimal route listed as a sequence of places. For this demo, I assumed that the first place is both the starting and the ending point. This way, the system generates a round trip bringing you back to where you started, which makes sense for most road trips. That brings us to the end of this demonstration. Hopefully, this automated route planner will be helpful for your next road trip. For your information, link to full code base and instructions are available in the description. To use it, you will need a free API key from OpenRoute service. If you spot bugs or have ideas to improve the workflow, do write back and we can discuss further.